We're now going to look at uniform motion problems. Tanya, who is a long-distance runner, runs at an average velocity of 8 miles per hour. 2 hours after Tanya leaves your house, you leave in your Honda and follow the same route. If your average velocity is 40 miles per hour, how long will it be before you catch up to Tanya? How far will each of you be from your home? What we're going to do to solve this problem is set up a little table. The table is going to contain the bits of information that we need. For example, we're going to have information regarding Tanya, and we're going to have information regarding the Honda. What do we know about the velocity of each? Well, we know that Tanya is traveling 8 miles per hour, and we know that the Honda is traveling 40 miles per hour. What do we know about the time? Well, the time is what we don't know. In fact, from the problem, we want to know how long it will be before the Honda catches up to Tanya. Let's call that our unknown. So T is going to be the amount of time that the Honda is traveling. Because Tanya left 2 hours earlier, Tanya is going to be traveling for T plus 2 hours. Finally, we want to know the distance. How far is each gone? Well, because velocity times time gives me distance, we know that the distance of Tanya is going to be 8 times T plus 2. We know that the distance the Honda is going to travel is 40T. I mean, just think about your own situation. If you were in a car traveling 30 miles per hour for 2 hours, you will have gone 60 miles. What we want to know is when will the Honda catch up to Tanya? In other words, when will the distance traveled be equal for Tanya and the Honda? Therefore, what we want to solve is 8 times T plus 2 equals 40T. We're going to distribute the 8. We get 8T plus 16 equals 40T. I'll subtract 8T from both sides of the equation. I get that 16 equals 40 minus 8, or 32T. Divide both sides by 32, and I would get T equals 16 over 32, which is 1/2. Because T is measured in hours, this is 1/2 of an hour. The other question that we want to know is, well, we know that they're going to catch up, or the Honda is going to catch up to Tanya after 1/2 of an hour, but how far is each traveled? Well, the Honda will have traveled 40 times 1/2, or 20 miles. And let's see how far that Tanya has traveled. 1/2 plus 2 is 2.5. 8 times 2.5 is also 20. So our answer checks. Both Tanya and the Honda have traveled 20 miles after 1/2 of an hour. We're now going to work constant rate jobs problems. These particular problems assume that a job is done at a constant rate over the entire amount of time it takes to complete the job. At 10 a.m., Danny is asked by his father to weed the garden. From past experience, Danny knows that this will take him 4 hours working alone. His older brother, Mike, when it is his turn to do the job, requires 6 hours. Since Mike wants to go golfing with Danny and has a reservation for 1 p.m., he agrees to help Danny. Assuming no gain or loss of efficiency, when will they finish if they work together? Can they make the golf date? The idea behind solving these problems, again, is that we are working at a constant rate. So if it takes Danny 4 hours to do the entire job, we assume that he completes 1/4 of the job in 1 hour. Then it takes Mike, working alone, 6 hours to do the whole job, so he completes 1/6 of the job in 1 hour. We're going to be combining the workload of Danny with the workload of Mike, so we take the portion of the job completed by Danny in 1 hour plus the portion of the job completed by Mike in 1 hour, and that gives us the portion of the job completed by the two of them working together. So we have 1/4 plus 1/6 equals 1 over t. What we need to do now is multiply both sides of this equation by the least common denominator. The least common denominator is going to be 12t. So we'll multiply the right side by 12t, and we'll multiply the left side by 12t. I distribute the 12t into the parentheses on the left. 12t times 1/4 is 3t. 12t times 1/6 is 2t. And over here on the right hand side, the t's cancel and we're left with 12. 3t plus 2t is 5t. So 5t equals 12. Finally, divide both sides by 5, and we get that t equals 12/5. Now 12/5 is 2 2/5, or 2.4 hours. So that's 2 hours. And then to find the minutes, take 0.4 and multiply it by 60 minutes per hour. 0.4 times 60 minutes gives me 24 minutes. Now because they started the job at 10 a.m., they're going to complete the job 2 hours and 24 minutes later. That's 12:24. So assuming that they're less than a half hour from the golf course, they'll make their golf date.